Hello class, today is lesson 9-1 in your algebra books, and it's learning how to graph the function y equals ax squared plus c. So to backtrack, a quadratic function is of the form y is equal to ax squared plus bx plus c. Right? We've worked with problems like this before where they were expressions and we know what the a and the b and the c were, but now we're going to be graphing these as it looks like a function. And in this particular section we're going to be graphing them where this bx is actually 0. Okay, so either the b was 0 and it got rid of the x, or the x is 0. But typically that's not going to happen. It's going to be the b that's going to be 0. And that's what this form is, ax squared plus the c. So we're leaving out the middle part for this section. And when we graph a quadratic function, it's going to look like a big U. All right? These are no longer linear functions, which means it's not going to be a straight line. It's going to look like a U. So when you're connecting all of the points of this function, it's really important to be connecting it in a U shape. Okay? So make it nice and round. Now we're going to go over a few things before we get into some specific ones. The first one is called the parent quadratic function. Parent quadratic function. And this is the most basic one. It is y is equal to x squared. So that means that the a was just the integer 1 and c was 0. So all we're left with is y is equal to x squared. So if I was going to graph this, I would just choose some points for my x's and my y's. I would plug them in and then I would graph them. So I'm going to choose my x's to figure out my y's. So I'm going to start with -2. When I square that, I get +4. When I plug in -1 and I square that, I get +1. Plug in 0 and I square that, I get 0. 1 squared is 1, and 2 squared is 4. So I'm going to plot these points so you can kind of see the shape of this parent quadratic function. So I have -2 up 4. I also have -1 up 1. I have 0, 0. I have +1 up 1. And I also have 2 up to 4. And there's many more points that I have for my function, but this is what I'm going to start with for the base of it. And I'm going to connect these dots, and as you can see, it's looking like a big U. And it's going to keep going up in the positive direction. Okay, this is known as the parent quadratic function. Okay, y is equal to x squared. Let's just talk about a few things. This point right here at 0, 0, in this case, is called the vertex. That means it's either the highest point or the lowest point of your parabola. That's this big U shape, the parabola. And in this case, it's the lowest point, so the vertex is at 0, 0 in this function. Okay. Another thing I'd like to show you is this line down the middle. This pink line, it's straight down the middle. This line is called the axis of symmetry. And what that means is that straight down this parabola, this imaginary line, is going to be a mirror image on either side of the line. So if I'm going to find a point here on the left-hand side, I'm going to find the same point, the same distance away on the right side. That's the axis of symmetry. Okay? So those are just a few of the terms that I wanted to go over. And so why don't we begin? The first one that we're going to look at is graphing y is equal to 3x squared. So again, let's pick some points, -2, -1, 0, 1, and 2. I always try at least 5 points. It'll help me get a good shape of my parabola. And I'm going to plug it in. So I'm going to plug in -2 here. That's going to be negative 2 squared, which is 4. 3 times 4 is 12. Plug in negative 1. Negative 1 squared is 1. 3 times 1 is 3. Plug in 0. Well, that's just going to be 0. Now I plug in 1. Again, it's going to be 1 times 3, which is 3. Plug in 2. 2 squared is 4. And 4 times 3 is 12. So when we go ahead and graph these points, I have negative 3 all the way up to negative 12. Or to positive 12, and that's going to be way up there, okay? So I'm just going to pretend it's way up there. You can't even see it. That's how high it is. I also have negative 1 up 3. I have 0, 0. I have 1 up 3. And I also have 2 up 12. So maybe on yours, you'll be able to actually put a 12 on there. So what I'm going to do is I'm going to graph this, and I'd like you to do the same. I'm going to try to connect this so that it looks like a U shape. That's actually kind of narrow. It's a little difficult for even me to do. Okay? Now, if I was going to graph that parent one that we saw before, okay, this green one, remember those points, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. I'm going to plot those because I want to see how it kind of relates to the parent one. So I have negative 2 to 4, negative 1 up 1, 0, 0, 1 up 1, and 2 up to 4. And I'm going to graph my parent linear function here. And what do you notice? It looks like this parent one is actually a little thicker than the one with the 3 in front of it. Okay? Looks like the one with the 3 in front of it is even more narrow. Now, why don't we try another one and see if that's the same kind of case? So I'm going to choose some points again, negative 2, negative 1, 0, 1, and 2. This time I'm going to plug it into the function y is equal to negative 2x squared. So plug in negative 2. When I square that, I get 4 times negative 2 is going to give me negative 8. Let's plug in negative 1. Negative 1 squared is 1 times negative 2 is negative 2. Plug in 0. 0 times anything is still 0. Plug in 1. 1 squared times 2, or times negative 2 is negative 2. And plug in a 2. 2 squared is 4. Negative 2 times 4 is negative 8. So now let's try these points. I have negative 2, and I'm going to go down to negative 8. That's about right there. I have negative 1. I'm going to go down to negative 2. 0, 0 again was right there. 1 down to negative 2. And 2 down to negative 8. As you can tell, it looks like this one is an upside down parabola. So I'm going to start down here. I'm going to bring it all the way up. And circle back around. Make it as nice and smooth as I can. And there you go. It looks like this one, which is a negative 2, is even more narrow than the parent linear function as well. Okay, except because it has a negative 2, do you notice it's going down in the negative direction, the way that it's pointing? This time its vertex is at the top. So the lesson that I want us to kind of get from this is that when you're graphing a function and it looks like it's the form y equal to some number, we'll say a, times x squared, and when this number a, whether it be positive or negative, is still bigger than 1 when you take the absolute value of it, such as negative 2, when I take the absolute value, 2 is bigger than 1. When this happens, you're going to find that the shape of it is going to be a narrower function when compared to the parent quadratic function. Okay, so this is just a good lesson for us to be thinking about. If we automatically see something, maybe it's y is equal to 10x squared, we should know it's going to be a very, very skinny parabola compared to this parent quadratic function. So why don't we move on? Let's see what other types of functions we might be graphing. This time I have y is equal to negative 1/4 x squared. So again, I'm going to choose some points. This time I'm going to choose negative 4, negative 2, 0, 2, and 4. Okay, I don't always have to pick the same points. So here we go. Let's plug in negative 4. When I square that, I'm going to get positive 16 times negative 1/4 is going to leave me with negative 4. Let's plug in negative 2. Negative 2 squared is positive 4 times negative 1/4 is negative 1. Plug in 0. Anything times 0 is going to be 0. Plug in 2. 2 squared is 4 times negative 1/4 is negative 1. And also 4 squared is 16 times negative 1/4 is negative 4. So why don't we plot these points? This time I have negative 4 down negative 4. I have negative 2 down negative 1. I have 0, 0. I have 2 down to negative 1. And I also have 4 down to negative 4. So I'm going to go ahead and I'm going to try my best to make a nice round parabola connecting these dots. It takes a lot of practice to get a good parabola. And I'm not the greatest, but I just go nice and slow. So there we go. Looks a lot wider, doesn't it? If I was going to plot that parent one, again, it would be negative 2 up 4. Be 1 up 1, 0, 0, 1 up 1, and 2 up 4. So if I was going to draw the parent quadratic function that I started out with, wow, do you notice that? Look at how much wider the pink one is. Right? And this is where it had a very small fraction multiplied times the x squared, okay, for the a. We're going to try another one. Let's try 1/2 x squared, okay. I'm going to try the same points, negative 4, negative 2, 0, 2, and 4. So when I plug in negative 4 and I square it, I get 16 divided by 2 is positive 8. Let's plug in negative 2. Negative 2 squared is 4. Divided by 2 is 2. 0 plugging in times anything is still 0. Plug in 2. 2 squared is 4. Divided by 2 is 2. And plug in 4. 4 squared is 16. Divided by 2 is 8. So let's plot these points now. I'm going to have negative 4. And I'm going to go all the way up to positive 8. It's way up there in the sky. Negative 2 all the way up to 2. 0, 0, 2 up to 2, and 4 all the way up to 8. And again, I'm going to try my best to connect these, make it nice and round. And look at that. The shape of this parabola is also wider than the parent quadratic function. You notice that? Look at how much wider it is. So the lesson that I want you to learn now is that when you're graphing the quadratic function and it's of the form y is equal to ax squared, so some number times x squared, but this time when you take the absolute value of a and it turns out to be less than 1. For instance, negative 1/4, when I take the absolute value of that, 1/4 is less than 1, and also 1/2 is less than 1. Then you're going to find a wider parabola compared to the parent function.